Hi, I'm Melinda Rose.
And I'm Ashley Paddock, and this is Light Matters for May 2nd, 2012.
On this week's show, a mock mission to Mars tests a camera design, coupling lasers leads to a blackout, a Femtolaser lightsaber targets diseased tissue, solar breakthroughs are announced, and we take a look at a light-based non-lethal device for law enforcement that's an alternative to laser-based devices.
The viability of a multiple camera system designed for future NASA space vehicles was the subject of a 2-week simulated mission to Mars by 5 engineering students from the University of Arizona. They developed the remote imaging system acquisition for their senior project, sponsored by NASA's Johnson Space Center. Future NASA space vehicles will have less room, so multiple cameras have to be incorporated into one system and work double duty as a camera for rover-based planetary surface exploration and for onboard use in space vehicles. The student researchers were holed up for 2 weeks in the Mars Desert Research Station, a simulated habitat managed by the Mars Society near Hanksville, Utah. They simulated living on Mars, including treating the outside environment as a space environment and using simulated spacesuits. The camera's electrically tunable multispectral filter was tested by imaging the atmosphere at specific wavelengths to determine water vapor content. The team still has some work to do before the project is ready for operation.
By coupling 2 microlasers together, one would expect more light to be emitted than from a single pumped laser alone. But coupling such lasers can, paradoxically, lead to a blackout where they shut each other off. The finding could prove significant for technologies that couple electronics and photonics. Scientists at the Vienna University of Technology, working with colleagues at Princeton and Yale and ETH Zurich, discovered the laser blackout effect by using new methods developed at TU Vienna. They found that when one laser is shining and the laser next to it is turned on gradually, complex interactions between the two can lead to a total shutdown of light emission. Surprisingly, pumping the second laser, too, does not necessarily increase the brightness of the coupled system, and supplying more energy can even reduce the brightness until both lasers become dark. The effect is not just about wave interference, but is a combination of interference and light amplification. And it is that combination which can lead to seemingly paradoxical effects which were confirmed in independent calculations at Yale. Electrical engineers at TU Vienna are now working to verify the theoretical predictions in experiments with actual microlasers.
A small, flexible endoscopic medical device fitted with a femtosecond laser scalpel can remove diseased or damaged tissue while leaving healthy cells untouched. The new medical lightsaber, designed at the University of Texas at Austin, would benefit patients needing surgery in delicate areas such as the digestive tract, throat, or brain. Made from off-the-shelf parts, it includes a laser that can generate pulses of light as fast as 200 femtoseconds. Based on a 2-photon fluorescence imaging technique, the specialized infrared microscope can penetrate up to 1 millimeter into living tissue, allowing surgeons to target individual cells or nuclei. The probe package is 5 times smaller than the team's first prototype, with an imaging resolution 20% greater. The optics includes a specialized fiber to deliver ultra-short pulses from the laser to the microscope, a 750 micron MEMS scanning mirror, and commercial lenses. The new design has been lab tested on pig vocal cords and rat tails, but will still need at least 5 years of clinical testing before it's okayed for human use. The research will be presented next week during CLIO 2012 in San Jose, California. So we recently marked Earth Day.
Yes, and that might be why there was a number of solar breakthroughs that were announced in the past week or so.
Yes, chemists at USC said they made a solar cell from small nanocrystals suspended in a liquid solution that can be printed or painted onto clear surfaces, which could lead to flexible solar panels shaped to fit anywhere. And Professor Eli Yablonovich and colleagues at UC Berkeley said they have created a prototype solar cell made of gallium arsenide that breaks efficiency records, an achievement they reached in part by designing the cell to allow light to escape as easily as possible. And both of these solar projects will be presented at CLIO 2012.
Also, scientists at Brookhaven National Lab said they have uncovered new details about the structure of one of the most efficient and best-known photovoltaic materials, which could inform the synthesis of new materials with even better properties such as displays, solid-state lighting, transistors, and improved solar cells.
Last week we reported from SPIE Defense Security and Sensing there were a number of new defense-related products on display, and our producer Charlie Rose talked with R.A. Lieberman of Intelligent Optical Systems about an interesting new use of LEDs for law enforcement.
I'm here to talk about the LEDI, light emitting diode incapacitator. It's a non-lethal self-defense device based on light, so we're using light as a weapon, as it were. This device is based on ultra-bright LED technology with a proprietary combination of colors and flash frequencies developed by the scientists here at iOS. So let me just demonstrate for you very quickly the effect. The way the device works is first it induces flash blindness with a very bright flashing light. The proprietary combination of flashing frequencies and wavelengths causes a sense of aversion in potential adversaries that winds up not just making them look away, but also degrades their performance if they're trying to come and do the user harm. So exposed to this for a long period of time, the combination of frequencies and colors makes it virtually impossible for the potential adversary to do the user harm. We are finding applications for this in law enforcement and in certain other government security applications. This form factor is meant to replace the conventional law enforcement flashlight, but other form factors such as fixed installations around portals, shields, and even helmets and vests are possible with this technology.
That's it for this edition of Light Matters, the industry's only weekly newscast. We'd love to hear from you. Tell us what you like or don't like about our program. We welcome your comments and suggestions at lightmatters@photonics.com.
You'll find links to share and subscribe to Light Matters by clicking the Share with Friends button on our video player.
Thanks for watching, and we'll see you next week.